All right, so you're gearing up for a master's thesis. You've definitely landed in the right spot. Now, this guide was originally born from the world of bioinformatics, but honestly, the advice here, it's pretty much universal for anyone tackling a big research project. Let's think of this as our playbook for turning that mountain of research into something you can be really proud of.
So let's be real for a second. Does the whole idea of this thesis just fill you with a special kind of dread? Yeah. If it does, you're definitely not alone. But what if we tried to look at it a different way? This isn't just some final chore you have to get through. No, this is your shot to go on a real intellectual adventure, one that you get to design completely from scratch. Okay, first up, substance. You can't just start building a house without a plan, right? You got to know what it's for, what you're making. Well, that's what this is all about. We're going to find your focus.
First things first, you should know that not all theses are created equal. You've got options. You might be doing a classic dissertation, trying to prove a hypothesis. Or maybe your thesis is tied to an internship, where you're getting that hands-on, real-world experience. You might even be doing a project where you actually build something. The real key here is to think about what you want to do. Are you using existing tools to solve a problem? Or are you the one who wants to create brand new tools? That answer is going to shape everything. And that brings us to maybe the most important question you need to ask yourself right now. In 3 to 5 years, where do you want to be? Seriously, are you thinking about the pharma industry, a university lab, a tech company? Your thesis is a huge stepping stone for your career, so you've got to pick a topic that actually gets you where you want to go.
Okay, let's also get one thing straight, because this is super important. A master's thesis is all about taking methods that already exist and getting new results with them. Think incremental improvements. It is not a PhD. For a PhD, you're expected to invent completely new methods to be disruptive. Knowing the difference and setting realistic goals is going to save your sanity, trust me. Especially now, in this age of AI, there are 3 things that are just purely human. We're calling them the 3 C's. Creativity, making new things. Curiosity, that's always asking why. And critical thinking, not just swallowing information whole, but forming your own take on it. These skills are what make you valuable, not the machine. And this right here is a golden rule of science. You have to record every single step. Because if someone else can't follow your steps and get the same result as you, well, it's not really science then, is it? It's more like a story. You need to keep records so good that even you, 6 months from now, when you've forgotten everything, can reproduce your own work perfectly. This is absolutely non-negotiable. Okay, so we've got our substance, our big idea. Now let's talk about structure. If that first part was the blueprint, this is us actually building the house, piece by piece. So let's break down the anatomy of a thesis. Pretty much every solid thesis follows this classic structure, right? You've got the abstract, that's your 30-second elevator pitch, the introduction, which is basically the entire thesis crammed into one chapter. Then you survey the related work, present your own work, show off your results, and wrap it all up with a conclusion. And what's holding it all together? The bibliography. Let's zoom in on that introduction because it is so important. Like we said, think of it as your thesis in miniature. You've got to hit these 6 points. 1, why should anyone care? That's your motivation. 2, what's the actual specific problem? 3, what's your big idea to solve it? 4, how are you going to do it? 5, give us a little sneak peek of your results. And 6, what did you actually create? If you can nail these 6 things, you've totally got your reader hooked. Now for the related work section. Please, please, please do not treat this like a book report. It's not just a laundry list of this person did this and then that person did that. No, this is where you join the scientific conversation. You need to look at what's already out there and say, okay, here's the landscape, and right here, this is the gap. This is where my work fits in. And while you're building that context, you have to watch out for some major traps. Warning number 1, legacy citations. I mean, just look at this, a paper from 1909 suggesting mercury to treat tuberculosis. You wouldn't cite that today, would you? It's absurd. The point is, your sources have to be current and they have to be relevant. Warning number 2 is a huge one. Be so careful about citing things that aren't proper peer-reviewed articles. Take this example. A single letter to a journal was cited over and over again as evidence that you couldn't get addicted to opioids. And we all know how that turned out. It helped fuel a massive public health crisis. So yeah, the type of source you use really matters. And warning number 3, always, always check if a paper has been retracted. I mean, this major Alzheimer's study was pulled, found to be bad science, but not before it was cited over 3,500 times. Imagine all the people who wasted time and money based on that. A quick check on the journal's website can save you from building your entire thesis on a foundation of sand. And of course, then we have AI. Let's be really blunt here. When you ask something like ChatGPT for sources, it just makes stuff up. A lot. It will literally invent citations that look real but are completely fake. So here is the golden rule. Never, ever, ever just trust an AI's sources. You have to check every single one yourself. Period. Okay, but what happens if your big idea doesn't work? What if your results are negative? First of all, do not panic. A negative result is still a result. And you know what? It's a valuable one. It shows you did the work rigorously, and it saves the next person from trying the same thing that doesn't work. Sometimes the process is way more important than the outcome. And when you're presenting your results, you have to remember that statistics are just a tool. They are not a truth machine. Think about it. A tiny p-value might suggest that someone winning the lottery twice has to be fraud, right? The odds are astronomical. And yeah, sometimes it is fraud. But other times, it just happens. People get lucky. The real world is weird, so don't just throw numbers at people. You have to interpret them and provide that context. All right, let's wrap up the structure with the finishing touches. Your conclusion is where you get to look back. What did you set out to do, and what did you actually accomplish? And where could this research go next? And for the bibliography, be a perfectionist. Seriously, even the fancy automated tools make mistakes. You need to go through it line by line. It's your final stamp of quality and integrity. Okay, we've talked substance and structure, the what and the how. Now for the final piece of the puzzle, style. This is all about how you polish your work and make all that effort really shine. So let's hit two big questions I know you're probably thinking about. How long does this thing have to be? And the answer is, as long as it needs to be. That's it. It just needs to be long enough for someone else to understand and replicate your work. Brevity is a virtue. As for tone, keep it clear, concise, and unambiguous. You're writing a scientific paper, not the next great mystery novel. And this is a big one. The jury, your professors, your readers, they want to know what you did. So write in the first person. Say, I developed this algorithm, or I conducted this analysis. Don't hide behind a vague we or that passive, it was found that nonsense. No, own your work. It's your personal contribution, so make that clear. Let's talk about AI one more time, but this time for writing style. The best way to look at it is as your personal assistant. Think of it like a calculator, but for words. It's great for checking your grammar, or maybe suggesting a different way to phrase something. But that is all it is. It's a powerful tool that assists you. It does not, and it should not, do the thinking for you. And this image just says it all, doesn't it? You've got all these inputs, your school, your advisor, AI, guides like this one. But at the end of the day, you are the one putting it all together. You're the brain in the middle doing the actual work. You have to harness the tools, absolutely, but you have to think for yourself. So what's the ultimate takeaway from all this? The paper you turn in is important, yes, but the real thing you walk away with? It's those 3 C's we talked about: your creativity, your curiosity, and your critical thinking. That is what this whole journey is actually about. Those are the skills that will stick with you for your entire career. So dive in, embrace the process, and hey, try to enjoy the ride.